All right, guys, so for tonight's notes, we're going to cover energy flow in ecosystems. So, energy, we need to recall and think about the fact that all of life's energy will come from the sun. That's the first, or the only place that energy can come from. And that's primary productivity, which is the rate at which producers make energy from sunlight. Factors that include that primary productivity or that rate include the amount of water available for a plant. It might be the amount of sunlight available to a plant, carbon dioxide, or some trace elements like nitrogen or potassium. So living things will fall into two categories depending on how they obtain their energy. They are either producers or autotrophs, and those organisms will produce energy by capturing sunlight or using chemicals, so plants, algae, and some bacteria. Otherwise, they are known as consumers or heterotrophs. And those are organisms that consume other organisms for food. Most autotrophs obtain energy from the sun through photosynthesis. So the energy from sunlight is used to power chemical reactions to make sugar. We did this in what I believe was our first trimester on campus, or our second trimester, where we looked at photosynthesis as a process. So consumers can be divided into further categories like herbivores, carnivores, and omnivores. Herbivores eat just plants, carnivores eat meat, and omnivores eat both plants and animals. This bunny would be an example of an herbivore. This cat is a carnivore. And bears are actually omnivores. While they will eat fish or other game, they'll also eat berries and plant life. We have these things called detrivores, and detrivores are organisms that obtain energy from dead matter or waste, so things like vultures or crabs or earthworms, and decomposers, which cause decay and release nutrients back into the environment, which is really important for the circle of life, like a bacteria or a fungi. Energy will actually flow through an ecosystem in one direction from the sun to autotrophs and then to various heterotrophs. Okay? Only one direction. These are known as trophic levels, or trophic levels are an assigned level in a food chain based on how an organism gets energy. So the first trophic level is always going to be assigned to a producer. In this case, on the bottom, it's a grass. And a food chain is the path of energy through the trophic levels. So energy is depicted with arrows. We start at the sun, energy moves to grass, to a grasshopper, to a shrew, to an owl. And above, you can see where they've fallen in the trophic levels. So we have energy, producer, primary consumer, secondary consumer, tertiary consumer. Typically, we see 4 to 5 available trophic levels. So this chart gives you a good idea of what we'd see and how that would be laid out with examples. So the food chain would be grass, mouse, snake, hawk, fox. Again, arrows pointing in the direction of good energy flow. A food web, on the other hand, there are multiple connected food chains, showing complex interactions within an ecosystem. So what does the owl feed on? According to this food web, it's snakes and frogs. But what does the grasshopper feed on? This plant with berries or the green leaves. There are 10 food chains in this one food web. You should challenge yourself to see if you can figure out how many you can find. I want you to write down in your notes packet one of the primary consumers, one of the secondary consumers, one of the tertiary consumers. You can even put just a P, S, or T next to the organism. And if there are any quaternary consumers, which is a fourth level consumer. When one organism eats another, They're only consuming a tiny part of the energy that's stored, and that's because there's so much energy used for life's processes, such as movement and reproduction, and some energy released as body heat and movement. So, seeds are using lots of energy for growth, and it's been stored. And whenever energy the mouse gets from the seeds, it will use it quickly for movement or growth. And the snake gains energy from the mouse, but again, uses energy to move around for life. We have this 10% law where only 10% of energy is passed from trophic level to trophic level. So energy is typically measured in calories or joules. So 1 kilocalorie or kcal is 1,000 calories. So if this set of seeds is 10,000 kcals, the mouse only gets 1,000 kcals, and the snake only gets 100 kcals, leaving only 10% of energy moving on. The energy pyramid is the diagram that represents the amount of energy stored in any given trophic level. It usually will depict the 10% law, with producers way on the bottom. Most of the energy is found on that first level. So as the pyramid moves up, less energy is available. So the more levels found between a producer and the top level, the less energy remains. So the bigger or the more levels, there's less energy at the top. So here's 1 million, 100,000, 10,000, and then 1,000 calories for our top carnivore. Biomass is the dry weight of living tissue or organic matter found within a trophic level. It typically measured in grams of organic matter per unit. So, most of an ecosystem's dry organic matter is found in the first trophic level of producers, and there must be lots of producers, so things like algae or plants, in order to support an ecosystem with higher level carnivores. So, think that killer whale is going to need thousands and thousands of pounds of primary consumers. The biomass pyramid will represent the amount of potential food available for each trophic level. And this is where we'll end our unit or our notes for the day.